So welcome along to Science Sketchbook's video on the particle model. A particle, for the purposes of this video, will be defined as a molecule or an atom. There are obviously differences between the two, but this is just a model, it's just a representation. So this is not exactly what you'll see under a microscope, but this is a zoomed in version of 3 different states of matter. So this one on the left represents a solid. This one will be a liquid. And this one will be a gas. Now, as you can see, I've had a head start because there are lots and lots of particles in a solid, and they're all in regimented straight lines in a grid. And they vibrate very quickly, but they don't have a huge amount of energy, so they all stay put. Now, liquid particles have got lots of energy, so I'm not going to draw lots of arrows on here, and this isn't a specific shape, but they are just all randomly bouncing around the place. So they've got lots and lots of energy. So if you give a little kid too much pop, too much Coca-Cola or Blue Smarties, they will be pinging around all over the place. And this is what enables a liquid to take the shape of a container that you put it in. That's one of the definitions of a liquid. It's how we describe a liquid. Is something that is in a state which takes the shape of the container. So if you pour a cup of coffee into a mug, as long as there's no holes in the mug, you will have coffee shaped like the inside of a mug or a bucket or a watering can, whatever. But they have more energy. These particles have more energy than in a solid, so they are moving around randomly. So when you draw a liquid, you need to make sure most of the particles are touching each other, but also that there's space in between them. That's how a liquid is represented in the particle model. Now a gas, on the other hand, is the liquid particles gone absolutely berserk, and they are flying around the place. It's tempted to draw arrows on these flying around, but that's not the proper way of representing a gas. So these will be bouncing off the sides of whatever it's in. Obviously, if it's in the air, then it'll be bouncing off everything. There'll be air pressure. If it's air inside a tyre, for example, these particles will be hitting the walls of the tyre very regularly, which is why a tyre stays inflated. So solid, not much energy, just lots of vibration. Nice straight lines, like soldiers. Liquid, bit more energy, moving around a lot, which is why it takes the shape of its container. And gas, pinging around like absolute mad things. It's suggested that you represent gas with about a dozen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've got 12 particles there. So let's just look a little bit more into how different substances, or one substance in particular, which we're going to look at, which is water, moves from a solid to a liquid, from liquid to a gas, and back down. And it's all about adding or subtracting energy. So water as a substance, H2O, in a gas form is called water vapor or steam coming out of a kettle. But that is still H2O. It is always H2O, so it's H2O in a solid as well, which is called ice. The fact that the chemical composition is the same all the way through means that what we're talking about here is a physical change. In another video, we'll talk about physical changes and chemical changes, but this is not a chemical change because we have the same chemical composition all the way through. If you add heat energy to ice, so if you put a flame under an ice cube, you will get water. Again, if you add heat energy, you will get a gas, which is water vapor or steam. If you put a beaker on top of a Bunsen burner, it will evaporate into water vapor. And again, if you go back down, so we'll use a different color again. If you subtract heat energy from gas, it will condense, so we've got evaporation and condensation back into liquid water. And if you subtract more heat energy, you will get ice at a very famous 0 degrees Celsius. And this point, I'm sure you've already guessed it, when it goes from a liquid to a gas, is 100 degrees C. One thing to note before I finish is that other substances will be in different states between different ranges. So a lot of substances are solids between 0 and 100 degrees C, and some are solids all the way up to very high temperatures, and some are gases all the way down to low temperatures. So obviously we are just talking about water as an example here. So you have to think about the melting points and the boiling points if you're faced with a question which asks which state of matter a certain substance is in, whether something is a solid, a liquid, or a gas.